Read the following passage and answer the question. When writing answers for the passage question, we have to read firstly first question and part 1, and then we have to read the paragraph to find the answer. Again we have to read second part, and then we have to read the paragraph. But I will read the paragraph now. Audible range of human ear extends from 20 Hz to 20 kHz. Ultrasound waves are also sound waves, but differ from audible sound only in its frequency. Ultrasound is used in many different areas, such as an industry, medicine, navigation, imaging, cleaning, mixing, communication and testing. An ultrasound transducer converts electrical signals into ultrasound waves and ultrasound wave into electrical signals. The key component of the transducer is piezoelectric crystal, which works on the principle of piezoelectric effect. When the high frequency alternating voltage is applied across such a piezoelectric crystal, it expands and contracts along one axis, producing ultrasound waves. Similarly, if ultrasound wave produces a variable pressure in the crystal, a small potential difference develops across the crystal. Therefore, the same transducer is used to generate ultrasound waves and to detect the reflected ultrasound waves. When ultrasound waves are incident on the boundary between two mediums, a part of ultrasound wave will be reflected and a part will be transmitted. The amount of reflection or transmission depends on a property called acoustic impedance Z of each medium, and it is given by the relationship Z equals rho V. Here rho is density of the medium and V is the speed of ultrasound wave in the medium. For normal incidence, the ratio of reflected intensity IR to the incident intensity II is given by IR divided by II equals Z2 minus Z1 square divided by Z2 plus Z1 square. Here Z1 and Z2 are acoustic impedance of the first medium and the second medium separately. Since Z value of skin is larger compared to that of air, when an ultrasound transducer is placed directly on the patient's onto a patient's skin, 99.9% of the incident ultrasound intensity is reflected and only 0.1% is transmitted into the body. In order to ensure that most of the ultrasound is transmitted into the patient, the special gel layer is applied in between patient's skin and transducer. Since the Z value of the gel is almost the same as that of the skin, very little ultrasound will be reflected, and this ensure effective imaging of internal structure. Figure 1 shows cross-section through a part of patient's body. Ultrasound is pulsed through the center of section so that it passes the first through an organ and then through a bone. Figure 2 shows oscilloscope trace of reflected ultrasound signals received from the skin boundary and then from the front and back surface, first organ and then bone. Part A1. What is the audible range of human ear? We have to write audible range. We know, and they have given in the paragraph 20 Hz to 20,000 Hz. Or we can write 20 kilohertz. Part B, name 3 areas that ultrasound are used. We can write industry, they have given in the paragraph. Industry, medicine, navigation, imaging, cleaning, mixing, communication, testing. They have to write only 3. I will write another one, imaging. Then part C, what is the function of an ultrasound transducer? It is given in the question. Expands and contracts along one axis. It expands and contracts along one axis. It is expanding and contracting ultrasound waves. Part D 1. Briefly explain how ultrasound waves are produced and ultrasound transducer. It also given in the question. When part D1, when a high frequency alternating voltage is applied across piezoelectric crystal, it produces ultrasound wave. Part 2. If the natural frequency of piezoelectric crystal is crystal in an ultrasound transducer is 48 kilohertz, what is the most appropriate frequency of the alternating voltage that should be applied across the crystal? Give the reason for your answer. It should be equal to the natural frequency. Therefore, we have to write 48 kilohertz because of it makes ultrasound by resonating piezoelectric crystal. It is compulsory, the word resonate. Part E. It is possible to apply same equation that is used to find the speed of sound in a medium to determine the speed of ultrasound wave propagation in the medium. Give reasons for your answer. We have to write ultrasound waves are, yes we can, because of ultrasound waves are a type of wave, sound wave. The difference between sound wave and ultrasound wave is only with frequency. Then you can write part E. Yes, ultrasound waves are a type of sound wave. We can write frequency greater than 20,000 Hz. It is the difference. Part F. In the expression IROI, so that the dimensions of IR is not equal to dimensions of Z2 minus Z1 square. We have to consider dimensions. Part X1. Dimensions of IR. Dimensions of IR. IR means intensity. Intensity is power divided by area. We know that sound intensity, light intensity is power. It means energy per second divided by cross-sectional area. Power. We know that energy is ml squared T minus 2. We have to divide by time to get power. Power means energy per second. Again we have to divide by area. Area is length into breadth L square. Then mt minus 3. Mt minus 3. It is dimension of IR. Then we can write dimension of Z square. Now in the relationship there is a difference between Z values. Dimension of difference also equal to the dimension of one Z quantity. And Z is, they have given Z is rho V. Therefore we can write rho V squared. Dimension of Z squared equals to dimensions of rho V squared. Rho is density ml minus 3 into velocity Lt minus 1 squared. Now m squared L to the power minus 3 into L to the power minus 2 squared L to the power minus 4 T to the power minus 2. Therefore, dimension of IR not equals to dimension of Z2 minus Z1 square. We are using this square bracket to word dimension. Part 2. What will be the value of IR divided by I if Z2 equals Z1? Now we have to consider IR means reflected intensity. I means incident intensity. Now, if Z2 equals Z1, it means ultrasonic waves will not reflected. Therefore, we can get when I1 equals I2, so when Z1 equals Z2, IR should be 0. Therefore, IR over IZ also 0. Then part 3, what will be the value of IR divided by I if IZ is greater than, I2 is greater than I1. If I2 is greater than I1, it means all waves will be reflected. All waves will be reflected. Therefore, IR equals I1. Therefore, IR divided by I1 equals 1. Part G. What is the reason for applying the special gel between patient's skin and transducer? A special gel layer is applied in between patient's skin and transducer since the Z value of the gel is almost the same as skin. Therefore, we can write answer for part G to make a same Z value. To make a same Z value. Or we can write to reduce reflection of ultrasound waves. Or we can write to increase the intensity transmitted to the patient. Part H. What is the acoustic impedance Z of human skin with density 1600 kilogram per cubic meter? If the ultrasound wave travels through the human skin, speed of 3750 meters per second. We have to use the given equation in the paragraph. Z equals rho v. It is given in the paragraph. Rho is the density 1600 into velocity 3750. There are 3 zeros. 375 into 16. 16 to 5 30. 3 remaining. 16 to 7 42 plus 3 45. 4 remaining. 16 to 3 18 plus 4 22. 1 into 5 5. 1 into 7 7. 1 into 3 3. 0 10 1 remaining. 2 plus 7 9 plus 1 10 1 remaining. 3 plus 2 5 plus 1 6. We have to consider the unit kilogram. We can write unit by using dimensions found for Z value. Kilogram m to the power minus 2 s minus 1. Or we can use directly density of unit of density kilogram per cubic meter. We have to multiply by velocity meters per second. We can get this unit. Then part 2, the average acoustic impedance of the material that the brain made of 4 into 10 to the power 6. Calculate the percentage of IR divided by I when ultrasound wave incident boundary of skin and brain. Now we have to consider, we have to use equation given in the paragraph. IR divided by IZ equals I equals I2 minus Z2 minus Z1 squared divided by Z2 plus Z1 squared. Now Z2 value is 6 into 10 to the power 6, this value. Z1 value is 4 into 10 to the power 6. I will get 10 to the power 6 as a common factor. And we have to get square of this term. Denominator 6 plus 4 into 10 to the power 6 squared. Now we can cancel out 10 to the power 6. 6 minus 4, 2. 6 plus 4, 10 squared. 2 squared 4 over 100, 0.04. Now we have to calculate the percentage. This one is fraction, therefore percentage. When finding percentage, we have to multiply 0.04 by 100, then 4%. Then part I. Part I1. Using the information given in the figure 2, determine the total time interval during which the ultrasound wave travels in the organ. We have to consider last part of paragraph. Figure 2 shows oscilloscope trace of refracted ultrasound signal received from gel skin boundary and then from the front back surface, first organ and then the bone. Now we have to consider the given graph. They have given a graph like this. And this is the time when the ultrasound wave is starting to move through the organ because of it is reflected from the gel skin surface, and when passing the organ, time is this one. We have to get this time difference. They have marked one square of given with these 5 microseconds, and between these two pulses there are 4 squares, 4 into 5, 20 microseconds. It is the answer for I part 1, 20 microseconds. In part 2, calculate the total distance traveled by the ultrasound wave through the organ. Ultrasound wave speed in the organ is 1600. Now we have to use SC equals UT for the ultrasound wave. We can use SC equals UT. Velocity of ultrasound wave 1600, time is 20 micro, 20 into 10 to the power minus 6 seconds. There are 3 zeros, 10 to the power minus 3, 2 into 16, 32, 0.32 meters. In part 3, hence calculate the thickness of the organ. When calculating thickness, we have to divide this value by 2. It means you can use first diagram, figure 1. If this one is organ, when passing this part and this part, it is getting the corresponding time, 20 microseconds. Therefore, we have to consider thickness is half of this part. In this method, we have to consider when only when passing tissue of organ, the time is taken for the taken as 20 microseconds. It means there is a cavity within the organ. We have to consider the time taken to pass the cavity is a smaller value for the ultrasound wave. Then we have to get thickness is 0.032 divided by 2, 0.016 meters. Then part 4, calculate the thickness of the bone. Ultrasound wave speed is 4100. Now we have to use same calculation for bone. When considering bone, we have to consider this part of the graph. It is 1 square. It means the ultrasound wave is getting 5 microseconds to pass the bone. Then we can get by using S equals UT, we can find the distance traveled by the ultrasound wave through the bone. I will consider bone is this one, from this point to this point. Then S is, we have to find S. Velocity is given as 4100. Time is 5 microseconds, 5 into 10 to the power minus 6. Now this one is the sum of this thickness and this thickness. There is a cavity in the bone. We have to consider the time taken to pass cavity is negligible. Therefore, thickness of the bone, we have to divide this value by 2. 4100 into 5 into 10 to the power minus 6 divided by 2. Then answer is 0.0103 meters. Part J, what is the reason for sending ultrasound pulse instead of continuous beam of ultrasound in medical imaging? We have to consider, we have to get reflected wave before giving next pulse. Then we can write answer for J, part J. We have to get reflected pulse by using oscilloscope before giving the next pulse. Part K, what is ultrasound scan safer over X-rays to examine the photos in womb. X-rays are electromagnetic waves. It will harmful for organs, but ultrasound waves are sound waves. Those are mechanical waves. It is not harmful. Therefore, we have to write X-rays are electromagnetic waves. Electromagnetic waves will be harmful for organs.